So as we were talking about today, we're talking about the triangle inequality theorem here. And the idea here is that if you were to measure these, you need to talk about these three lengths. So these first ones, the lengths turn out to be 4.3 centimeters. You could use different units, I guess. This is 6.9 centimeters. This is 10.2 centimeters. Okay? Again, what I would do is I'd probably put the 10.2 here on the bottom somewhere. I don't know, maybe prop up the 6.9. And what's kind of cool is since you do have the 3-in-1, you can kind of swing this thing a little bit, like this way or this way a little bit. You can actually use, make it 69 millimeters, and now you can actually use that as the circle part of your 3-in-1. And then you can basically go from here and make this 4.3, and let's just say this goes out to like here. You can kind of swing this back and forth, and where this thing intersects is where you need to put the point. Okay, so that's a pretty easy way of doing this in case you were struggling doing this. The idea is this is the 10.2 down here. This is one of the shorter ones. This is one of the shorter ones, and you can basically swing it back and forth using the circle part of it if you change it into millimeters. Okay, so the first one should have definitely worked, but the second one does not work, and we can see that pretty easily by just writing down the lengths. The lengths here, this is 9.6 centimeters, this is 5.1 centimeters, and this is 3.5. So if you put 9.6 centimeters down here, even if we just raise this like 1 degree, this is 3.5, this is 5.1, you can definitely tell there's going to be some sort of gap here. There's no way you can possibly get those connect because it only adds up to 8.6. There's no way that it can stretch the entire length. Okay, so this one would not work at all. Yes, sir. Okay, with number one, all I did is I found out the lengths. Okay, I drew the longest one on the bottom, just like this. Okay, and then what I did is I took my 3-in-1 because I didn't know if you just put it out there, it's probably not going to be the exact length, right? There's only one correct place that would give you the exact length. So what I did is I translated these numbers into millimeters, and that's basically what all these little numbers on here mean. Okay, these mean millimeters. So this is basically my center. I would put that like right here. This is the center of the 3-in-1, and then say I had to move 6.9 centimeters. Well, I'd go to the 69 on here, and basically I'd draw like a little arc that would look like this. That would be kind of somewhere in here. Anywhere on there is like exactly 6.9 centimeters from this point. And then what I'd do is I'd go from here, I'd go exactly, 4.3, and I'd draw another arc like this, exactly 4.3 centimeters away, where those two intersections where I have to put the point. Okay, does that make a little bit more sense? So there's one reason it's really nice to have a 3-in-1 versus just having a ruler for this, is because you're able to do those things. So in case that comes up at another point. Okay, explain the process. That's the process that I did. What did you discover? Probably what you discovered is that I don't know if I was going to make any sense. Like when you have, I don't even know how to say this. When you have any three lengths, they don't necessarily make a triangle. And I don't know what you wrote, what you discovered, but this is basically what I found. What is something someone else discovered when they did this? Anybody else discover something different? Yeah. Yes, so the legs, there's a certain range of which the legs have to be. That's the idea. And we could phrase it in a couple different ways, but I think what you've said and what I wrote down are those two things are mainly what you have. Is that, if you have any three lengths, well, you can't just have any three random lengths and form a triangle necessarily. Okay? Sometimes, yeah, it works, and most of the time, yeah, it does work, but not always. Okay? So the sum of the lengths of any two sides of a triangle, well, it's either going to be greater than, less than, or equal to the length of the third side. What do you guys think? Okay, so I'm gonna write this as either greater than, less than, or equal to, and we're gonna pick which one of the three that is. Okay, so let's go back to this one here. Here's less than, because basically I'm saying, hey, 3.5 plus 5.1 is less than 9.6. Is that gonna work? Okay, so less than is not gonna work. God bless you. Okay, what happens if I had equal? I don't know what I wrote there. I should say 3.5. 3.5, okay. What if I had equal to? What if this was 8.6? Okay, would that form a triangle? Would that form a triangle? No, it wouldn't, because you basically have, here's the 8.6. In order to get this to work, you basically have to lie this right on top of here. This would be the 3.5, this would be the 5.1. And is that a triangle? No, they're just lines just hanging out there. So is equal to going to work? Yeah, equal to is not going to work either. Okay, so let's go back to this original example. The reason I know this is going to work is because 4.3 plus 6.9, well, that's going to be greater than the 10.2, and that's going to work out just fine. Okay? So these two have to be just a little bit greater than, because they have to account for the slight angle they're going to be at. Yes, ma'am, what's your question? That's correct. Yep. So equal to doesn't work, less than doesn't work, it has to be greater than the length of the third side. Okay, so for instance, earlier I'd given you this idea of 4, 7, and 18. Okay? Why doesn't that work? Using this theorem. Mitchell. Okay, so right, it says the sum of the lengths of any two sides. So 4 and 7, well, they're not greater than 18, are they? So that doesn't work. Okay, but look at the other examples. You could have said, well, hey, but 18 plus 7, well, that's definitely greater than 4. And 18 plus 4, well, that's definitely greater than what's my other one, 7. So that works. This one works, that one works. But this one here doesn't work. Okay? So really the one that we always test is, hey, smallest one, second smallest one, how does it relate with the biggest one? Okay? After that, what we did is I said, well, hey, maybe not 4, 7, and 18, but what about 4, 7, and 1? Will that work? How many people think yes? Raise your hands. How many people think this will form a triangle? How many people think no, it won't form a triangle? How many people have no idea? Okay, there's a couple people that don't know. So here's the deal. You always have to add together the two smaller ones. So 1 plus 4. Is that greater than 7? Well, if the answer is no, it's not going to work. Okay. What about 4, 7, and 3? Will that work? Let's try it out. We have 3 plus 4. Is that greater than 7? No, it's equal to 7, so that won't work either. Okay, what about 4, 7, and 11? Will that work? 4 plus 7, is that greater than 11? No, it won't work. Okay, so there's kind of this rule that we have here. And here's how it works. If I'm given two sides like 4 and 7, okay, and I need to figure out my range of values for the other two, it's actually really easy, okay? Let's just say that my third side is going to be x, okay? The way that I figure this out, the range of values, I'm just going to do this. All I do is I subtract these two numbers. So this is 7 minus 4, which is 3. So it has to be greater than 3. And I add these two together, so 4 plus 7, that's 11, goes right here. So my range has to be somewhere between 3 and 11. Any number between 3 and 11 will work. So if I said, hey, 4, 7, and 6, will that work? Yeah, if I said 4, 7, and 10, will that work? 4, 7, and 10.999, will that work? Yeah, it will. Okay? So the idea here, all I did is I said, well, I know these two numbers. My third one's going to be x. All I do is I subtract the two sides, add the two sides. That's going to be my range. Okay, let's try this again. Determine whether it's possible to draw a triangle with the sides of the given measurements. Mine has more space than yours does, but it'll work the same way. Will this one work? What do we have to do? Yeah, add the two small ones together. So 16 plus 30. Okay. Is that greater than 45? Yeah, this is 46. 46 is greater than 45. So the answer there is just yes. Okay. Number 2. Well, 9 plus 17, you just add the two smaller ones. So you compare that to 28. That's 26. Is 26 greater than 28? No. You're right now. I think this is an okay explanation. I see what you're doing. As long as you're writing down that math stuff, that's going to be your explanation, okay? So when I see this step here, and all of a sudden you say yes or no, based on it, I understand what's going on because you're using the triangle inequality theorem. Okay, let's try this. If 17 and 36 are the lengths of two sides of the triangle, what's the range of possible values? Range of possible values. Well, I have 17, I have 36, and I'm going to have x. I put x in the middle. How do I figure out the smaller one? Correct. So you say 36 minus 17. What's 36 minus 17? 5? It's 9, isn't it? Or 19? Sorry, 19. Okay. And then how do I get the bigger value? Yeah, you just say 36 plus 17. Is that 5? Oh yeah, 53. Okay. So my range of values is just 19 to 53. Could it be 19? No, that won't work. Could it be 53? No, but anything in between there, not counting those two numbers, will work. What do you guys try the last one? Slightly easier numbers to work with. And you're just going to pretend that it's x, because it's the unknown side length. Unless it tells you differently. If you subtract the two numbers, 45 minus 25 is 20. If you add them together, 45 plus 25, 70. It's really just that easy. That your range is between 20 and 70, which is a huge range for which your possible lengths it could be. Okay, your guys' assignment is that next page. I don't have it on here, but that next page, and it's basically a balance of these last 4 problems we just did, describing whether they're going to work, yes or no, and maybe to provide some sort of explanation. 9 and 10, finding those range of problems. I really like the range of problems. The 9 and 10, I think they're really good problems. And the last 4, basically you are writing measurements of triangles and saying whether they're going to work or not. I think. Make sure to read the directions. Make sure it makes sense to you. If you have questions, make sure to come and talk to me or Mrs. Gant, because she's definitely staying after school. She can help you guys as well.